In the paper helicopter lab, you're going to hone your experimental skills. We're going to discuss the independent and dependent variables of different exercises that we'll use at paper helicopter, changing one thing or another about the helicopter and seeing a result. Remember that we always change the independent variable. That's what we're testing, what we're changing on purpose. But the dependent variable is what we measure as the result of that change in what we changed on purpose. So we change something, the independent variable, and then measure the result, the dependent variable. Anything that we keep constant throughout the experiment is called a constant. We keep it the same. For example, I might drop the helicopter from the same height every time, but change something else and see the result. First, I'm going to explain how to make your paper helicopter using the template that's on the lab.
First, you'll need one of the paper helicopter templates. You'll just need one of these, cut out along the dotted line. You'll see there's a labeled X and Y. Those are the fins of the helicopter, the blades, the wings as it is. And then A, B, C, and D. Now, we found that it's actually better not to cut it here, but just a little bit lower on both sides. And then you're going to fold A, B, and C together to form the bottom stem of the helicopter. And it does help if you fold up the little D flap at the bottom. Next, we'll cut down between X and Y to make the fins, stopping here where we will fold it. To begin with, in the experiment, we'll fold it so that Y is facing up. Here is your finished helicopter. But not quite. It does help to add a paper clip to the helicopter to start with. So add one paper clip to the bottom of the helicopter for a little stabilizing weight. And there it is.
Once you have your helicopter finished, if you drop it, you'll see that it starts to spin. Depending on the direction that the wings are folded, it will spin a different way. So let's test that first.
First, we'll drop our helicopter with the Y facing up. Question number 1. Watch how it spins. Does it go clockwise or counterclockwise? Ready? Watch. 3, 2, 1. Maybe it was a little fast. Let's do it one more time.
3, 2, 1.
Now, we'll switch the wings so that X faces up. And we'll drop it again and see which direction it spins.
One more time.
It may be hard to tell, but with Y up, it should spin clockwise. With X up, it should spin counterclockwise. In experiment 2, we're going to add weight to the helicopter by adding a paper clip each time. If you're using large paper clips, change the number of paper clips to 1, 2, 3, 4, 5, and 6. If you're using small paper clips, leave it the same and go up to 10. So there are 3 possible outcomes for this experiment. 1, as we add weight, it could fall to the ground faster. Or if we add weight, it may fall to the ground slower This may not be your first instinct, but it is a possible outcome. And of course, C, it could have no change on how the object falls. Weight may not matter at all. What would we keep constant each time that we do this experiment? You'll see that we're changing the number of paper clips and we're measuring the time to fall. Each time we'll do 2 recordings and take an average. If you're following along and watching this video, just record 1 time with each drop. You'll complete this table and then graph your data. You'll need to find your own y-axis scale based on your longest time that you've recorded. Then we'll see what the data does.
As you follow along in the video, it's going to be your job to record the time that it takes the paper helicopter to drop and fall to the floor. We'll begin with 1 paper clip, and it's important that we keep this as accurate and as consistent as possible. I'll try to drop the helicopter at the same height every time and give you enough height so that you can start and stop your timer. Please follow along with your phone's timer app or a stopwatch, or pause the video and record the timestamp, and then pause the video again when the helicopter hits the floor, and record the difference in the video's time. Any way you do it, you'll be able to record the time that it takes the helicopter to fall, and then chart that on your graph. I am going to stand up on the chair. I don't recommend you doing that at home. If you're doing this on your own, please be careful. It's hard to drop the helicopter and record the time at the same. So we'll begin with 1 paper clip. I'm going to keep the fins consistent with the X up. I'm going to drop it from this height. I'll give you a countdown, 3, 2, 1, and then I'll drop. You start recording. 3, 2, 1, drop. And stop. Now we're going to add a paper clip. We're going to add 1 large paper clip each time. So change your chart to be 1, 2, 3, 4, 5, and 6 paper clips instead of the 10 if you're using the small. We'll do 2 this time. 3, 2, 1, drop. That was better. We'll add another paper clip and drop it again. 3, 2, 1, drop. We'll add another. Oh, 1 fell off. You should have 4 paper clips now. 3, 2, 1, drop. Now we add our 5th. 3, 2, 1, drop. And 1 more. For a total of 6 paper clips. 3, 2, 1, drop. You should have noticed that as we added weight to the helicopter, it fell faster. So our independent variable, the weight of the helicopter, caused a noticeable change in our dependent variable, the time it took to fall. Once you have all your measurements, make sure to chart your data on your graph. For experiment 3, it's your turn to do your own experiment. I'm going to leave it up to you to see what you come up with doing. Don't add weight this time. Do a separate, different experiment. How could we change the helicopter and record that change as a testable experiment? Maybe we could cut parts off of the wing by a certain amount each time. Maybe we could change the orientation of the wings. Add more wings. Cut the length of the stem down. We could do it with smaller paper clips since we used the large paper clips this time. See if that makes a difference. Anything you can change and then measure a result makes an experiment. Just be sure that you keep things constant every time as best as you can.